All right, we're going to get into 7.3 today. Um, what we're going to look at in 7.3 is when you have a right triangle, we're going to draw in that altitude that we talked about in chapter 5. When you look at your altitude, the one altitude of a right triangle that is not drawn with the original triangle would be AD here. So if I'm looking, oh, I'm sorry, AC. So when I'm looking at AC here, notice that altitude meets that bottom at a right angle. What we are going to learn today is that there's going to be some relationships that are built there when that happens, right? Before we get there, though, keep in mind, anytime we have right triangles, the easiest thing to always look for is can you use Pythagorean theorem to find our missing side? So right here we have this x squared is going to equal 3 squared plus 4 squared. So we have x squared equals 3 squared is 9, 4 squared is 16. We add them together and we get 25. To solve your equation, we take the square root of each side and we get our answer to be x equals 5. And as we talked about, in a right triangle, we are going to draw in this altitude. So here we have this triangle ABC. The altitude we are going to draw in is going to go from our right angle to our hypotenuse. That is your altitude. Now, later on in the period, we're going to talk about how that altitude is going to break up your different pieces. But for the first part here, what we have to realize is we have 3 right triangles now. If I call this point D, we have this big right triangle that's there, which was triangle ABC. We have the top left triangle, which was triangle ABD. And we have this bottom right triangle now, which was triangle BDC. What we need to be able to do is realize all 3 of these triangles are actually similar, and we're going to learn how we can go through and match up their sides and make these proportions that we made in chapter 6. Right? In order to do that, we're going to learn it 2 different ways. Right? So the first thing we're going to do, the first thing to go over is that altitude of a triangle, as we said. It is the perpendicular segment from a vertex to the opposite side. Technically it says, or the line that contains the opposite side. So here, this altitude, it is x. Now what we're going to learn to do today is go through and find those other pieces. Maybe we'll learn to find x here, or maybe we'll try to find y, or maybe we'll try to find z. Right? There's going to be different ways that we can do it. One way we're going to learn, which will be the second way, is what's known as that geometric mean. If you remember your geometric mean that we did before, it's just going to be this little proportion that was here. We learned how to find the geometric mean of maybe 4 and 9. So the geometric mean of your values, we did x and x, and then 4 and 9. When we cross multiply, and we'll get our answer. Right? It's going to be a little bit different today because we're going to talk about finding what's called the geometric mean of a leg or your geometric mean of an altitude. Right, but we'll worry about that in the second half of class. The way we're going to do it at first is going to be by looking at our similar polygons. Remember, we talked how we're going to have these 3 right triangles. Those right triangles are all going to be similar to each other, which means their sides are going to be proportional. And their corresponding angles are going to be equal. The difficult part, though, is they're not all drawn the same way. So if I look at my 3 triangles that are here, we have your big triangle, then we have what I'm going to call the top left triangle, and what I'm going to call the bottom right triangle. Right? And we have a lot of issues going through and trying to figure out what pieces are supposed to match up. So I'm going to give you a 3-step process that is going to allow you to do it every time. The first step, well, I should say 4-step process, I guess. The first thing we're going to do, is not really part of the step, is we're going to draw 3 triangles that all look the same. Our triangles are all going to look like the big triangle that's there. So you notice I've already redrawn triangle ABC. That is my big triangle. Now, we need to make the 2 small ones match it. So we're going to start with the bottom right one. Right, when I look at this bottom right triangle, it's right here. Okay? The three-step process starts with, what are the three letters that make your triangle? In this triangle, it is A, it is D, it is C. The second step is, what is the right angle of that triangle? If I look at for the right angle, here's my right angle. That is vertex D. So D has to go at my right angle. That means we have already used D up. That leaves us with A and C to place. Now, one of them has to go in the same place as the big triangle. So if I look at A, for example, if I try to choose A is at the right angle in my big triangle. If I try to put it there in my triangle, it's already blocked. There's already a letter there. So I cannot pick A. If we pick C instead, when I look at my big triangle, C is this bottom right angle. When I go to my triangle, C is, there's nothing there. So I am allowed to put C here. And then I can put A up top then. I have now redrawn that triangle so that we can match the pieces up. Right? Now that left-hand side will match the left-hand side. So if I had something like x over 8 and 3 over 6, we'd be able to figure out that x had to equal 8 based on the sides that have to match up. We also can do it, we're going to do it again here, and we're going to do this multiple times today. We are also going to do it for the top right triangle. So there's our top right triangle. The first question, again, remember I'm going to ask you 3 questions. The first question is, what are the 3 letters that make it? Those would be points A, D, and C. I'm sorry, A, D, and B. A, D, and B. Second question is, which one is the right angle of our triangle? Well, if this is a 90-degree angle, then this is a 90-degree angle. So my 90-degree angle is still point D. So D is gone for my choices. That leaves me with A and B to pick from. So we pick one. Maybe I pick B this time. If I look at my big triangle, B is up at the top. If you look at our triangle, there is nothing there to stop me from putting it there. So that is where B would go. If we had picked A, when you look at A is the right angle of our big triangle. When you go to try to put it there, there's already a letter there. So I cannot put A in the same place. That's why we actually had to pick B. We just happened to pick it right, which means A then has to go down here. Then what they're going to ask you to do, one of the questions will be to write a similarity statement. Well, our triangles are already drawn the correct way. So if I name my first one ABC, my second one can be named triangle DAC. I'm just going in the matching orders. And that's going to be similar to triangle DBA. Right? And then we can also then use them to find our missing pieces. Right? That idea is our theorem 7.5. If the altitude is drawn to the hypotenuse of a right triangle, then the 2 triangles formed are similar to the original triangle, and they are similar to each other. What we need to learn to do is figure out how are they similar. How are these sides going to match up? What sides match with what? And if you redraw them, it's a lot easier to find. So let's take a look at our top one here. First thing you should do, I'm going to draw 3 triangles that all look like our big triangle here. So our big triangle had the right angle up at the top. It was F, it was G, and it was H. I'm going to draw 2 others that look just like it. In this case, we have a left-hand triangle and a right-hand triangle. We'll start with the left one. So here's my left triangle. I want to know, first question is, what three letters make it? So that would be F, that would be G, and that would be J. The second question is, which one will be our right angle of that red triangle there, of this triangle on the left? Well, since this is a right angle, this is a right angle. So it is point J that is our right angle. Point J is now gone from our choices. That leaves us with F and G. So we pick one. If we pick G, when I look at my big triangle, G is the right angle. When I come to my triangle, I already have a point or a letter at my right angle. So I cannot put it there. So instead of picking G, I'm going to pick F. In my big triangle, F is in the bottom left. In my triangle, there is nothing written there. There is no vertex there yet. So I'm going to call that F, which means G goes in my last vertex that's there. Now to do the triangle on the right. When I look at my triangle on the right, I'm looking at this triangle here. First question, what three letters make it? That would be G, that would be H, and that would be J. Second question is, which one is the right angle? Looking at my triangle, it is angle J that is my right angle, so angle J must go there. The third question is, which one are you going to pick, G or H? When you look at your big triangle, G is at the right angle. That's not the one you want to pick. I want to pick the other one. I'm going to pick H. In my big triangle, H is in the bottom right, so that is where H is going to go. Which leaves me with G then to go in the bottom left. So to write our similarity statement then, we say triangle, and I can name my big triangle however I want. I'll name it triangle FGH. Triangle FGH is similar to triangle. Now when I go to this left-hand one here, I'm going to name that FJG then. Just going in the same order. Similar to triangle, now I'm going to do GJH. Okay? Just making sure these pieces all match up. Right? Once again, going to my second one here. I have my big right triangle here. Our big one is NLM. Now we have a top left, and we have what I'll call a bottom right. Let's start with the bottom right. We're going to make this triangle look like my big triangle here. So here's my bottom right. First question is, what three letters make it? Those three letters would be P, L, and M. Second question is, which one is the right angle? In my bottom right triangle, that would be angle P. Third question is that I pick one. We're going to pick L or M. L is the big right, or is the right angle of my big triangle, so that is not the one you want to pick. Instead, I'm going to pick M. M goes in the bottom right. When I look at my triangle, there is nothing written there, so that is where M is going to go. Which leaves me then with L to go up top. Now, when we do our other one then, triangle LPN, once again, we're going to spin it around and make it look like this triangle, my big triangle. So here's my top left. The three letters that make it are P, L, and N. My right angle is angle P. That leaves us with L and N to choose from. Looking at my big triangle, angle L is my right angle. That is not the one I want to pick then. So that tells you that I want to pick angle N. Angle N is what's up top. So angle N has to go up top, which means L goes down on the bottom right then. When we identify our similar triangles here, we can name our big triangle however we want. Me, I'll name it triangle NLM. It's similar to triangle. Let's do the bottom right one. So that's the blue one over here. If we do NLM for the first, we do LPM for the second, and we do NPL for the third. Right? And then it will just be labeling our figures, which is what we're going to get into next. Right? So, first question is going to be identify our similar triangles. So, once again, we're going to start with our big triangle that's there. Our big triangle has our right angle, and it was D, G, E. And then the values we have are 8, 6, and 10. Now, let's take a look at our two small triangles. Let's do the top right one first. So I'm going to draw it so it looks exactly like my big triangle. So this is the top right. The three letters that make it are D, F, and E. Your right angle of that triangle is F. So F goes at your right angle. Your two remaining choices then are D and E. We picked one. Right? When I look at my big triangle, D is at my right angle. I'm not going to be able to place D then. So I have to pick E. E is off here, over here to the top right. So that is where E goes, which means D goes down here. Now to label that triangle, DE was 8. DF was 10. DF was X. My other triangle that we need then is what we call the bottom left triangle then. Once again, I'm going to make it so it looks just like the other two. The three letters that make it are G, F, and D. Your right angle is F again. Now we have G and D to pick from. When you look at your big triangle, D is at my right angle, so I do not want to pick D. That tells me I need to pick G. G is on the bottom right, so G will go on the bottom left. So G is going to go on the bottom left. That tells me that D then goes off to the right there. Filling in our pieces, we have FG, they don't have anything for. FD was our X, D to G was 6. So first question, identify our similar triangles. Triangle, name your big one. G, D, E. It's similar to triangle. Let's do the top right. That would be DFE. Similar to triangle, now we'll do the bottom left. That would be GFD. Next question then is find that value of X. Knowing everything that we have up here then, we need to match one of our X's to something. So take a look at this X right here. This X matches up with this 6. So I can do X over 6. If we do X over 6, then I look at this 8. This 8 matches up with this 10. So I have X over 6 equals 8 over 10. And then we cross multiply. 6 times 8 is 48. X times 10 is 10x, and we divide. We get x to equal 4.8. Right, same thing in your next one then. It says the cross-section of a group of seats at a stadium shows a drainage pipe, BD, that leads from the seats to the inside of the stadium. It says, what is the length of our pipe? So once again, we're going to look at all three of our sides. We have A, B, C. That is our big triangle, where it is 20, 30, and 10 square roots of 13. Let's do our bottom right triangle. We're going to spin it around so that we make it look just like our big triangle. Our right angle now is D. The 3 points we had to choose from were B, D, and C. As I said, we already used D. That was our right angle. That leaves us with B and C to choose from. If I look at my big triangle that I'm trying to match it with, B is my right angle. I can't put it there. So it is C that has to match. Since C is in the bottom right, C goes in the bottom right. That leaves B to go up here. Now we fill in our pieces. BD is X. And B to C is 30. Right? All we're trying to do is find X. We have what we need. X will match up with our 20. They are both on the left-hand side here. That's why we take the time to do this. X over 20 will equal, now I got my 30 to match with this 10 square roots of 13. Now, since it doesn't tell me that it needs to be in exact form, I can put this as a decimal. So that 10 square roots of 13, that is just a decimal. So we'll treat it as that. 10 times the square root of 13 and we get 36.05. So I have 36.05 times X equals 20 times 30 is 600. And now we divide. We get 16.64 as our answer. Now, before we do our next one here, we're going to get into working with how else we can do this. Okay? In order to do it our second way, we are going to do what we call that geometric mean. However, to do a geometric mean, there's going to be two of them. There's going to be what we call a geometric mean of a leg and a geometric mean of your altitude. Right? And the key is going to be, can we label a right triangle? When you look at a right triangle, we've talked before how we have two legs and a hypotenuse. This new thing that we are adding in today, we have this altitude here. That altitude breaks your hypotenuse up into two pieces. Right? We're just going to call them piece 1 and piece 2, just because they're two different pieces. They're not going to be split evenly. Right? That's only going to happen in a rare circumstance. If you can find and label these 6 pieces, all you have to do is know 2 formulas to plug in. And that's what we're going to learn now. Your geometric mean of an altitude. Your altitude, since it's called the geometric mean of an altitude, it would be your altitude that will go in twice. So they're going to have some type of number or letter there. Your altitude meets your hypotenuse and it breaks it into 2 pieces. It is those 2 pieces that go into the other parts of your proportion. Right? So if I look at the example we have, is there anything written here on our altitude to use? No, there is not. So we're not going to use our geometric mean of an altitude. However, there is also a geometric mean of a leg. The way that works, since it is called the geometric mean of a leg, the leg will go in twice. Now, the pieces that go with a leg are going to be your whole hypotenuse and one of the pieces. The way we determine which piece, we want the piece of the hypotenuse that is closest to the leg we are using. Right? So here's what we mean by that. When I look at my picture, we already said we have nothing on our altitude. Do we have something on one of the legs? One leg would have been here. The other leg is here. Well, right here I have a Y. So it is the Y that goes in twice. So it is the leg and the leg. Now we need the whole hypotenuse. When you're looking for the whole hypotenuse, we want to go the whole length of the big hypotenuse that's here. So that would be 15. And then one of the pieces, there are two pieces of our hypotenuse. There's the 4, and then there's this piece, which would be 11. We want the piece that is closer to the leg we are using. Well, that would be our 4. So here's our equation. When we cross multiply, we get y squared equals 60. And then we take the square root of each side. So we have y equals the square root of 60. However, in the directions, they tell us to put it in simplest radical form, which means we need to reduce this square root of 60. A perfect square that goes into 60 is 4. 4 times what? It is 4 times 15. The square root of 4 is 2. So we end up with 2 times that square root of 15. There are no perfect squares that go into 15, so that is what tells me that that is reduced completely. So as I said, there are 2 geometric means that we have. There is our geometric mean of an altitude. So if you look here we have an altitude that is x. It is the altitude that would go in twice. And then it's the 2 pieces of our hypotenuse. So that would be piece 1 and piece 2. So it would be 11 and 40. Oh, I'm sorry, not 44. 11 and 4. And then we're just going to go ahead and cross multiply. So that's our geometric mean of an altitude that we have there. So in a right triangle, the altitude from the right angle to the hypotenuse divides that hypotenuse into 2 segments. The length of the altitude is the geometric mean of the length of those 2 segments. So I'm going to do altitude with altitude. And then it is piece 1 and piece 2 of our hypotenuse. There is also your geometric mean of a leg, as we went over. Right? Geometric mean of a leg, it is the leg that goes in twice. Right? So it's leg and leg. It's always going to be the whole hypotenuse. And then the other piece is going to depend on which leg you choose to use. If I'm using leg AC, for example, the piece we want to use is AD, because that's the piece that's closer. If we are doing this leg, we're going to do piece BD, because that's the piece that's closer. And we're going to do plenty of examples of these over the course of over the course of your homework and in class and going forward. So let's take a look at our example then. It says, to find the clearance under an overpass, you need to find the height of the concrete support beam. It says you use a cardboard square to line up the top and bottom of the beam. Your friend measures the vertical distance from the ground to your eye and the distance from you to the beam. Approximate the height of the beam. First thing I see there is approximate. That means I am allowed to round my answer here. So they even draw me the nice little picture for it. In this picture, as I said, you need to be able to identify our pieces. So here's our right angle. That means that this is our hypotenuse. This is a leg. This is a leg. This piece coming through the middle is our altitude. So we need to identify, do we have one of the legs to work with? Or do we have the altitude to work with? Whether it's a number or a letter there is not going to matter. This 6.9, it is pointing to our altitude. We don't know either leg, so we need to do the geometric mean of an altitude. That says it's the altitude that will go in twice, and then it is piece 1 and piece 2 of your hypotenuse. Well, that altitude breaks our hypotenuse into 2 pieces. There's your hypotenuse. So our altitude was 6.9. Piece 1 and piece 2 of your hypotenuse, that would be our x and our 5. So we cross multiply here. 6.9 times 6.9 gives us 47.61. 5 times x gives us 5x. Finally, we divide. We get x to equal 9.52. So it says to approximate the height of the beam. The height of the beam then is 5 plus 9.52. So we're looking at 14.52 feet for our height. Right, 2 last examples here. And our first one says find the value of y, writing our answer in simplest radical form here. So once again, identify our pieces. We have a leg, and we have our altitude. Which one has a number or a letter with it? Well, that would be our bottom leg. It has a y to it. So I'm going to do our geometric mean of a leg. It says the leg goes in twice. Then it's the whole hypotenuse. And one of the pieces, the piece closest to the leg we're using. Our leg was y, so it's y and y. The whole hypotenuse was 24. Now the 2 pieces, I got my 9, and that would mean this piece here is 15. Which piece is closer to the leg we are using? Well, that would be our 9. So there's our proportion to solve. Cross multiply y times y is y squared. 24 times 9 gives us 216. So we take the square root of each side. I have this y equals the square root of 216. Since they said simplest radical form, I cannot put this as a decimal. I need a perfect square that goes into it. Our perfect square that goes into it would be 36. It is 36 times 6. So the square root of 36 is 6. And there are no perfect squares that go into 6, so we are done. There's our answer for y. Brings us to our last one. It says the distance from the ground to Larry's eyes is 4.5 feet. How far from the beam, in example 4, would he have to stand? Well, we now have to go back to our beam in example 4. That beam, the height of the beam we said was 14.52 feet. So here's that beam. 14.52 feet. It says the distance from the ground to Larry's eyes now is 4.5 feet. They want to know how far away does Larry have to stand to measure its height. So they want to know our x. Once again, label. We have leg, altitude. Which one do we have to work with? In this case, it is your altitude. Whether it's a number or a letter does not matter. The altitude goes in twice, and then it is the 2 pieces of our hypotenuse. So the bottom piece was 4.5. The whole thing was 14.52. So 14.52 minus our 4.5 tells me the top piece is 10.02. To do the geometric mean of an altitude, it is the altitude that went in twice. And then it is our piece 1 and piece 2. It is the two small pieces. So that would be 10.02 and 4.5. X times x is x squared. 10.02 times 4.5 gives us 45.09. And then we take the square root of each side. And we get 6.71 for our answer. Right. And here's your homework then for section 7.3. Please let me know what questions we have.